Good morning or good afternoon, everyone. Thank you for joining us in the fireside chat. In my presentation, we'll be talking about polyphase or multiphase machine, and we'll see how we can model it in Flux and FluxMotor. So first, let's quickly talk about the multiphase machine. As you might know, the main advantage of this machine is that it has a better segmentation of the power. So it gives a better reliability of the machine, and especially it helps designing power electronics because less power is in play in those type of machines. Also, the more phase you have a better fault tolerance of your machine, because if one phase gets broken, you have more phase that will take the lead from it, and you will have a better reliability on your machine. And also, the waveform will have a better shape. We'll see this afterward. You have higher torque density and quality, but also less noise and less rotor losses because, for example, the back EMF has less harmonics. Same thing for your torque and stuff like that. Although this machine seems to have a lot of advantages, there are still some drawbacks to use it. The first is that we lack some experience in the control design. So nowadays we are really used to having three-phase power electronics. It's a little bit harder to design an n-phase electronics, but yet it's still possible to do it. And also nowadays the charge that you will plug into your motor or your generator are often three-phase. So you will need one more step of conversion between your generator and your system. But apart from that, the machine seems really good to use, and it's already used in many applications. So here is a quick list of applications of this type of machine that we have seen, either as electric vehicles, for wheel engines, for traction vehicles, also in the naval or aerospace industries. They are sometimes or often used, and also in the power generation. We can see either polyphase machine or multiphase machine for this type of applications. That was it about the introduction, little quick introduction. Now I will dive directly into FluxMotor to show you what has been done and how you can model this type of machine in FluxMotor. So once you reach the motor catalog in FluxMotor, you have here two catalogs of n-phase machine. As you can see here, it's written here n-phase, n-phase. And when you enter it, you have either inner motor machines or outer rotor machines. And if you double click on one of the catalogs, you can start designing a new machine, and it will become a machine in your user catalog. So I've already opened one of the machines here. And from this point, when you have the machine opened, you can modify its topology the same way as if it was a three-phase machine. You can, for example, here you have 5 phases, 7 phases, you can change to 5 and put as much pole as you want. And just by one click, it will adapt your geometry. You can add housing, shaft as usual, and also you have a simplified tool for your winding architecture here that you can use in order to modify the way you want your machine winding architecture. So it works quite the same as the three-phase machine. If you're used to using FluxMotor, I feel like you would be able also to do it for 7-phase or 5-phase or whatever number of phase machine. For now, there are no tests available on this type of machine, unfortunately. We might be working on that in the next versions, but the most interesting things that you have is that in one click, you can directly export your model to Flux and open it. So I haven't modified the input of the test, but you might do it if you want. And also you can do an export for working point IPCN usual test. If you want an open circuit test and compute the back EMF and your cogging torque. And you can also do a magnetostatic model of the machine if you just want to, if you need it magnetostatic for another type of application. So with this click, as you have seen, the Python script that generates the machine has quickly been created. A Flux window gets open, and with this Flux window, you will obtain your project as you defined it in FluxMotor in a quick click. So this is our 5-phase machine. Now I'll dive back to the presentation. Once you have your machine in Flux, you might want to analyze and see what happens when you change the number of phases of your machine and see how it affects your performances. So what we want to show you today is a small analysis we have done where we take a machine, so this is a previous machine, and we will modify its stator in order to have 3, 5, 6, or 7 phases. And here is the phase agency of your machine. And from that, we can run the flux resolution and obtain multiple electromagnetic parameters, such as, for example, the induction, the magnetic field ISO line, and the magnetic flux density ISO values here that you can see. You might also compute the back EMF. And as you can see, that's what we talked at the beginning of the presentation. The more phases you have, I mean, the less you will have effect of the harmonics on your back EMF and also on your torque, because here, as you can see, with more phases, you obtain a better mean torque, but also you have a lot less torque ripple in your machine. So you might want to consider having more phases, but you have to discuss the number, because as you can see, the 5 phases here seems less good than the 3, 6, or 7. There is also something else that you might want to do on your machine, is to compute a reduced order model of it in order to use it in system software such as PC, Morpheus, and Activate. This can be done the same way as the 3-phase machine, because we have developed in the macro multi-phase motor analysis folder some macros that will compute automatically lookup table for the machine. They work the same way as the 3-phase machine, except that now you can select any number of phases you want, of current sources, sorry. And from that, you can obtain usual lookup table that you know about. So here we did it for the 7 phases motor. You have the flux, the torque, and also inductances, static and dynamic. But also you have Joule losses that I haven't displayed here. Furthermore, last thing we want to show on the machine, starting from this lookup table, you can also analytically compute efficiency maps of those machines. So this is done using a compose script. It's in fact the same compose script that is also used in backend in SimLab. And from that, you can verify, for example, the torque of your machine and see that the max torque obtained in the efficiency map is approximately the same as the mean torque that you compute in the transient magnetic computation we showed 3 slides ago. So that's it. This is also efficiency map. So basically, in this presentation, we saw that you can effectively compute the N-phase motor in Flux and FluxMotor. You can easily design the machine in FluxMotor and then export it to Flux in order to run a usual analysis of your machine. Also, since the 2022.2 version, there is a macro inside of Flux that allows you to compute the lookup tables of those type of machines. Thank you for your attention.